Section 7.1, example 2, eliminating the parameter. So eliminate the parameter for each of the plane curves described by the following parametric equations and describe the resulting graph. Ooh, okay, so let's do a quick sketch of the graph beforehand just to see what it looks like first and see if it matches what we end up with. So let's start with graphing. We have t going from -2 to 6. X of t. So -2, that's going to be 0. -1. √2, that's going to be 2. √5. 2 √10. 2 √3. √14. And 4 over here for y of t. So -4 and y -3. -1. 1. 3. 5. 7. 9. 11. And 13. So we have that. Let's see what the result looks like. All right, x goes from 0 to 4. Y goes all the way up to 13. All right, 0, -3. And then we have a 2, 1. And we have a 4, 13. All right, after careful deliberation, it kind of looks like parabolic shape going this way. All right, let's see if it matches when we actually compute everything. Okay, so the one thing that each of these equations have in common is t. And since we're used to having y as a function of x already, what I want to do is solve for t here and then plug it into this equation. So let's solve for t over here. So we have x is equal to the square root of 2t plus 4. And solving for t, we have x squared is equal to 2t plus 4. And actually, let's see, t is going to be equal to x squared minus 4 over 2. And now that we have something for t, we're going to plug it into our equation right here. We have y is equal to 2t plus 1. We'll say that y is equal to 2t. We have this function here, x squared minus 4 over 2 and plus 1. We have y is equal to x squared minus 4 plus 1 is going to be a minus 3. So this here is a parabola that shifted down 3 units, which is 1, 2, 3. What we have right there. And perfect. That's it there. But more importantly, we are not in terms of t anymore. So let's figure out what our parameters are here. So what values of x suffice this equation? So x, we could literally just look at what x does. So x goes from 0 all the way up to 4. So we could say that 0 less than or equal to x less than or equal to 4 are our equations here. And there we go. If you have any questions whatsoever, please feel free to ask. Otherwise, bye. Oh, I lied. No, we have another equation. Look at me trying to rush out of here. All right, same thing here. But instead of graphing this first, I'm just going to jump straight into the actual equation. So with these, we have to be a little more particular. So one thing I do see is we have cosine and sine, and we could use the Pythagorean identity to kind of help us out with graphing this or finding the parametric or the regular function. So what I'm going to do is set these equal to each other respectively. So x is equal to 4 cosine t. I'm going to get cosine t by itself, and I'm going to get sine t, or yeah, sine t by itself. So over here we have cosine of t is equal to x over 4. Over here we have sine of t is equal to y over 3. And with our Pythagorean identity, we know that sine squared t, doesn't matter what t is, theta t, a sine squared t plus cosine squared t is equal to 1. We have something for sine, so that's going to be y over 3. Y over 3 squared plus cosine, we have this for cosine. So we have x over 4 squared, that's all equal to 1. Let's fix it up because what we have here is an ellipse. X squared over 16 plus y squared over 9 is equal to 1. That's an ellipse with a major axis as an x-axis, 4 and 3. So we come over here. Actually, not there. So x goes up 1, 2, 3, down 1, 2, 3, and out 4 units. One, two, three, 4. 1, 2, 3, 4. And there we go. We have 4, -4, 3, and -3. And that's the graph here. So let's see, where are we at when we start? So we started at 0. Cosine of 0 is 1. So x is equal to 4. So we're starting off here. So starting off here, and we go in this direction here. So this is t is equal to 0. And there we go. Simple as that. And now, if you have any questions, please feel free to ask. Otherwise, bye.